Hello, it is Mr. Kingsbury, and we are here today talking about the characteristics of rational functions. We've actually already talked about this topic once, but we're going to talk about it again. And as I start this, I realized I didn't put my essential question down there. That's okay. I'll write it in as we go, I guess. Anywho, we're looking at our rational family of functions, and as I said, we're going to look at characteristics. Again, this is Algebra 2. Don't forget to put the period that you have me and the date you're looking at this. Our essential question today is going to be this: how do I identify the characteristics of a rational function that is not in transformation form? There we go. Sorry I didn't have that written out beforehand, but it is what it is. So we're going to look at 6 different things. In the previous video, we talked about vertical and horizontal asymptotes. We looked at the x and the y-intercept, and we looked at the domain and the range. I believe that is also 6 things. Hey, look at that. Well, we're going to drop range on this one because when it's not in transformation form, it's difficult to figure out what the range of a rational function is. But we are going to add another piece to it, something called a whole. In fact, let's just talk about all that for just a moment. We talked about asymptotes, and now we're going to talk about wholes, and all of those are something we call a discontinuity. This is anywhere the function is not, or a function is not defined. Anywhere a function is not defined. There are several of them. We're going to focus on asymptotes, asymptotes, and something called wholes. We talked about asymptotes in class a little bit, I think. We also talked about it in the last characteristics video. That is a line that, you know what, let's just define this. So an asymptote is a line that a function gets closer to without ever crossing. It certainly that area is undefined. The function is not defined for that x value. It's a single point that is undefined. So we'll be looking at those. There are actually vertical, horizontal, and slant asymptotes. We're just going to look at vertical and horizontal ones. And then wholes, well, a hole is a hole. There's only one kind of hole. It's kind of interesting to see it on a graph. We're going to talk about these for a couple days in class, but I wanted to get you the different information here. So to begin with, I just want to tell you that all of the problems we give you for this type of characteristic, 2 things are going to be true. 1, they will not be in transformation form, and 2, they will be factored. I could give you long polynomials and force you to do the factoring, but for reasons of time, we're going to go ahead and give you factored quadratics and trinomials and polynomials and that kind of thing. That's going to save you some time, I promise. So let's go ahead and look at an example. And I'll write out a whole bunch of stuff, and then I'll do a few more examples, and we can use those notes to kind of figure a few other things out. So first example that I have looks like this. It's a great example. We're going to do y equals x minus 4. Let me rewrite this. Y. Nice. Of course, I grabbed the pencil. That's crazy. There we go. So y equals Can't win for losing. Y equals x minus 4 times x plus 2. That's in the numerator. Oh my goodness. And then on the bottom, we are going to do x plus 2 times x plus 8. And we need to look at all these different things. So let's start with the whole. This is a really good way to start things. The whole will have the same binomial, or the same factor, if you will, on the top and bottom. In this case, it would be x plus 2. So you take that, you set it equal to 0, and you solve. So I'll subtract 2 from both sides. X equals negative 2 is my whole, and that's how you would write it. X equals negative 2. Once you've done that, the stuff that's left on the top and the stuff that's left on the bottom, those are going to be important things. One of them is going to be your vertical asymptote. And that will be any factor on the bottom after eliminating the holes. Whoops, that is the wrong version of the word whole. That would be whole like complete. I need whole like incomplete. That's interesting. Anyway, so if we go back to our example here, x plus 2 was the same top and bottom. So that's my whole. Once I get rid of that, and I'm just looking at the bottom here, what's left on the bottom is x plus 8. So I would take x plus 8, set that equal to 0, and solve by subtracting 8. So x equals negative 8. That's going to be my vertical asymptote. I am going to jump then to x-intercept, because its definition is very similar to vertical asymptote. This will be any factor on top after eliminating the whole, or the holes. Should put holes like that. So in this case, where'd we go? Up here. So once we eliminate x plus 2, what's left on the top is x minus 4. So we set that equal to 0. We add 4. We get x equals 4. Please write this one as an ordered pair. Whatever you solved for, comma, 0. So those three go pretty quick. And as you can see, I've run out of space, so I'm going to go to the next page. But yeah, those three go really, really quick. And the domain actually will follow from that pretty quick as well. And then we can talk about the Y-intercept and the horizontal asymptote. So let's go to the next page, and we will do example 1 continued. And let's see, that would be y equals x minus 4 times x plus 2 over x plus 2 times x plus 8, like that. And just a quick review. We already identified x plus 2 as the whole, right? This is the whole. This is the x-intercept. And this was the vertical asymptote, which is good. Interestingly enough, the domain follows from that very quickly. And in fact, once you have the vertical asymptote, the whole, and the x-intercept done, actually you just need the vertical asymptote and the whole, you can write the domain. Remember we said that for rational functions, we're going to write the domain as what x cannot equal. Well, we just defined what discontinuities there are. We defined what things are not. I'm not saying that right. We already identified what places are undefined here. We got x equals negative 2 and x equals negative 8. Those are undefined, so they cannot be in the domain. So x is simply not equal to negative 2 and negative 8. So that's my domain, which is pretty cool. I love that 4 of these 6 things come very quickly. Here's one, whole, vertical asymptote, x-intercept, and then when you take your answers to whole and vertical asymptote and you simply make x not equal to those, that's your domain. So I like it when it follows quickly like that. Then we have our y-intercept, which is pretty easy. To do that, we will substitute 0 in for x. So y will equal 0 minus 4 times 0 plus 2 over 0 plus 2 times 0 plus 8. And let's be honest, because I have a same factor top and bottom, I don't even need to worry about this. I worry about those two. So really, I just need to worry about the 0 minus 4 and the 0 plus 8. 0 minus 4 is negative 4. 0 plus 8 is 8. So I have negative 4 over 8, which reduces to negative 1/2. And I can write that as an ordered pair, 0, comma, negative 1/2. So there's that. All of those follow pretty easy. I did save the most difficult one for the end, though. In order to find the horizontal asymptote, you have to compare the degree of the numerator and the degree of the denominator. And I'm going to need to clarify that. So let me write that down. Horizontal asymptote. Compare degree of the numerator to the degree of the denominator. And right now you guys don't know what degree is. A degree is the biggest exponent. So let me see if I can help you figure that out here. To do that, what you do is everything that has an x in it, multiply that. So for us, we would multiply x and x on top, and on the bottom, we would also multiply x and x. So I'd get x squared on top, x squared on bottom. This has a degree of 2. This also has a degree of 2. And I'll do a couple of examples where the degree is different. Once you compare them, though, then based on how they compare, you've got to do one of 3 things. So you got one of 3 options. Either the bottom is bigger. When that happens, your horizontal asymptote is y equals 0, always. If the top is bigger, there is no asymptote. If the top is bigger, there's technically a slant asymptote, but we're not going to look at it. So as far as we're concerned, there is no horizontal asymptote. And then if they are the same, then you make a fraction out of the coefficients. So in this case, for the example that we're doing here, we had x squared over x squared. They're the same. So I'm going to make a fraction out of the coefficients. The coefficient of the top is 1. The coefficient of the bottom is 1. So I have 1 over 1, which is 1. So my horizontal asymptote would be y equals 1 for this. That's the one that is the most difficult and that we're going to need to practice the most. It does not help that this is already in factored form. Truth be told, finding the horizontal asymptote is easier if it's not factored, but these other ones, the vertical asymptote, the x-intercept, and the wholes, that's easier to find when it is factored. So you got to have it one way or the other. We're doing the factoring version, so you don't have to worry about it. Certainly all you have to do is multiply the x's, just like I mentioned. So let's just do a couple of examples now that I've shared them with you. A couple more examples. And lay that out. Give you a little practice, what have you. So how about, let's do this. We're going to do y equals x minus 3 over x plus 3 times x minus 1. And we will find the vertical asymptote, the horizontal asymptote, the x-intercept, the domain, the y-intercept, and, oh, I forgot holes. I believe I forgot that. Holes. Now we can do x-intercept, y-intercept, and domain. Different order. Doesn't matter the order, really. I'm probably going to skip around anyway. So, for starters, do I have anything? Actually, I meant for this to be a plus. Sorry. Interesting. Do I have anything that is the same top and bottom? And I do right here. X plus 3. So I set x plus 3 equal to 0. Subtract 3 from both sides. X equals negative 3. That's going to be my whole. X equals negative 3. Next up, I see I have this thing on the bottom. That's my vertical asymptote. So I'm going to set x minus 1 equal to 0. I will add 1 to both sides. X equals 1 is my vertical asymptote. I don't have anything left over on the top. That means there is no x-intercepts. Except none. And then my domain, I can put x is not equal to these two values here, 1 and negative 3. Then I'm going to jump to y-intercept. I plug x in here. Remember I said that anything that's the same top and bottom we can get rid of. So just pretend that it's 1 times that. So this leaves y equals 1 over x minus 1. And what we'll do is put a 0 in place of that x. 0 minus 1 is negative 1. So I have 1 over negative 1, which is negative 1. So my y-intercept is 0, comma, negative 1. And lastly, I have my horizontal asymptote. So to do that, I need to compare the degree of the top and the degree of the bottom. So on top, I have x squared on the bottom. The bottom is bigger. Therefore, y equals 0 is my horizontal asymptote. And that's how you do that. And right now, you're probably fairly confused. I would be surprised if you weren't. It's not that any one of those is terribly difficult, but there are so many of them and so many little pieces. So it does not surprise me if you're freaking out a little bit. So let me do another one. How about this? Let's do y equals x times x minus 1 times x minus 4. And that will be over x plus 5 times x minus 4. I always like to start with the holes. So, is there anything that's the same top and bottom? Yep, right here. So my hole, I take x minus 4, I set it equal to 0. I'll solve by adding 4 to both sides. X equals 4 is my hole. Then I like to take what's left over on the bottom. That's my vertical asymptote. And I set that, so what's left on the bottom is x plus 5, and I set that equal, oh my gosh, pencil, to 0, and I solve. So x equals negative 5 will be my vertical asymptote. Probably domain would be good next. Simply x is not equal to 4 and -5. And yeah, I know I've written it differently before, but this is how you're going to see it on the test, so I thought I'd write it that way. Then we have our x-intercept. So let's see, got rid of those. That was my vertical asymptote. What's left on the top? I actually have x and x minus 1 left on the top. So I need to set them equal to 0 and solve. This one is already solved. So I've got 0, 0 as one of my x-intercepts. And look at this. I add 1 and I get x equals 1. So 1, 0 will be the other x-intercept. There are actually 2 here. When you start to get these funky rational equations, you can have stuff like that happen, unfortunately. But hopefully you won't see too many of those. So far, so good. Next, let's do our y-intercept. So I'm actually going to come up here. We're going to get rid of these things at the same top and bottom, and I'm going to put 0 in for x. So y will equal 0 times 0 minus 1 over 0 plus 5. So, whoops, that should be 0 minus 1. So I get 0 times -1 on the top and 5 on the bottom. That's 0 over 5, which is 0. So my y-intercept is 0, 0. So far, so good. Lastly, horizontal asymptote. So on top, the terms that have an x would be x, x, and another x. And then underneath, the terms that have them are x and x. And when I multiply that, I get x cubed on top and x squared on the bottom. The top is bigger. So according to what we discussed earlier, if the top is bigger, then there is no horizontal asymptote. There's actually a slant asymptote. But like I said, we're not going to get into slant asymptotes because, yeah, they're not fun. So, anywho, let me do one more, and then we'll put an end to these notes, which have gotten pretty long, truthfully. I didn't think I was going to need quite this many pieces of paper, but apparently I do. There we go. So last example. What is this? Example 4, something like that. Here we go. Let's do, on top we'll do 2x times x minus 5. On the bottom we will do x plus 3 times x minus 4. So let's start with wholes. Do I have any factors that are the same top and bottom? The answer is no. So we're going to put none. Then we will do our vertical asymptote. Anything left on the bottom, that's both of these. Those are going to be vertical asymptotes. So I have to set them equal to 0, both of them, and solve. So this one I will subtract 3. I get x equals -3. This one I add 4. I get x equals 4. Those are both my vertical asymptotes. So I've got 2 of them. Then let's look at our domain. It's going to be x is not equal to any wholes in any vertical asymptote. So in this case, -3 and 4. Next up, our x-intercept. So what's left on the top now? That would be 2x and x minus 5. I need to set them both equal to 0. So here we have 2x equals 0. I need to undo the times there. That's 2 times x equals 0. If I divide both sides by 2, I get x equals 0. So one of my x-intercepts will be 0, 0. And then over here, I will add 5 to both sides. So x equals 5 is the other one. So we'll put 5, comma, 0. So far, so good. Let's do our y-intercept next. That means we're going to plug 0 into all of these. Unfortunately, I don't have any of that at the same top and bottom. So I don't have anything that cancels out. That's a bummer. But what do you do? So we'll go y equals 2 times 0 times 0 minus 5 on top. And then on the bottom, 0 plus 3 times 0 minus 4. And let's see. So on top, 2 times 0 is 0. 0 minus 5 is -5. On the bottom, 0 plus 3 is 3. 0 minus 4 is negative 4. So on top, 0 times negative 5 is 0. 3 times negative 4 is 12. 0 over negative 12 is 0. So my y-intercept is 0, 0. Almost done. Last but not least, my horizontal asymptote. We need to compare the top and the bottom, the degrees of the top and the bottom. So on top, I have 2x and just x. And then on the bottom, I have x and another x, right? Anything with an x in it, I'm going to multiply. That gives me 2x squared over x squared, or if you will, 1 squared. They are the same, which means I need to make a ratio out of this, which is just 2. So my horizontal asymptote is y equals 2. We're going to spend a couple days practicing all of that because that is tough. That is challenging. There's a lot of little pieces and there's a lot to remember. So if you're not quite getting it right now, that's okay. Don't worry. We will address it in class. Appreciate you looking at my video, and I'll see you in class. Bye. And I'm done. Sorry about that.